Alright, so I'm trying a problem. I have never solved it, and it's called the time when the network becomes idle. A very long statement and a web diagram and whatnot. Let's try to have a read. Let me zoom in a little bit as well. Okay, it's already zoomed in, which is good. This is a network of n servers labeled from 0 to n minus 1. Okay, we are given a 2D integer array edges where u edges I equals to uv indicates that there is a message channel between servers u and v, and they can pass any number of messages to each other directly in 1 second. You're also given a zero index integer array patience of length n. All servers are connected, that is, a message can be passed from one server to any other server directly or indirectly through the message channels. The server labeled 0 is a master server, rest are data servers. Each data server needs to send its message to the master server for processing and wait for a reply. Messages move between servers optimally, so every message takes the least amount of time to arrive at the master server. The master server will process all newly arrived messages instantly and send the reply to the originating server via the reversed path the message had gone through. At the beginning of second 0, each data server sends its message to be processed. Starting from 1 second, at the beginning of every second, each data server will check if it has received a reply to the message it sent from the master server. If it has not, it will resend the message periodically. The data server I will resend the message every patience I seconds. That is, the data server I will resend the message if patience I seconds have elapsed and the last time the message was sent from the server. Otherwise, no more resending will occur from this server. The network becomes idle when there are no messages passing between servers or arriving at servers. Return the earliest second starting from which the network becomes idle. I think definitely need some example. So we look at this example. So in this example, input is edges and patience. So edges between 0 to 1 and 1 to 2. So 0 to 1 and 1 to 2. It's a simple this, and 0 is our master and 1 and 2 are the data servers. Patience is 0 to 1. So I guess always the source will never have the master will never have any patience. These two have patience of 2 and 1. Okay. So initially it's second 0. Both of them 1A, if this is a patience. Okay, yeah, so both of them send a message. Now what happens is this will receive here, this will come here. What is this 2B? Hmm. So obviously after 1 second, this guy will send another. What will they send? Do they resend the packet or what? It will basically resend the same message. Okay. So yeah, it has not received, and so it starts sending. That's how. And the third is when, oh man, at the third second, at the second. Okay, at here, uh, it's yeah, I responded. It got here, this got here, this got here, and it starts again, and it also starts another one. Why is this called 2B? Okay, 2B. So there has to be 1B also, no? At this point. Oh, because it received, it didn't have to send. Interesting, right? Yeah. So this was good. Now there is no one involved anywhere, which is great. And now there were three packets. So 2A was here. It would respond to, so 2A will come here, which is nice. 2B will go there, and 2C will come here, and this will start another one. This guy keeps sending. Okay. And at some point, I wonder if it will always keep on happening. Like when does it actually stop? Maybe when it receives a response from, right? So this receives a response to it. So now 2 is gonna stop, and all of these uh, will come to this, and will slowly send the response. Okay, so got the idea of it. Interesting, interesting problem. And yeah, the explanation is fine. This is another one, 0 1 2, edges 0 1 2, patience 0 10 10, output equals to 3. Data servers 1 and 2 receive a reply at the beginning of the second 2. Uh, just about 1 and 2. So 1 and 2, yeah, and they're waiting for 10 seconds. So at beginning of the uh, 0 is at the start of 1, start of 2. Yeah, I don't understand. So at the start of 1, the packet is here. At the start of, so yeah, okay, this is a bit confusing. The 1 and 2 will receive a reply back at the beginning of second 2, which is true, right? At the beginning of second 2. So from the beginning of second 3, the network is when network become idle. So plus 1 is your answer. Okay, it is definitely an interesting problem. Time the network becomes idle. Hmm. So essentially, uh, we have to find from each node. For example, in this case, from 2, right? Between 2 and 0, there is a distance of 2, and there is a, a patience of 1. So distance of 2 means it will take twice that amount of time for that packet to become quiet, right? So it will take, for a single packet, it will take 4 units of time, and but its patience is 1. So that means 4 minus 1 is 3. So it will actually send 3 more extra packets. Yeah, is it becoming math? Like, so essentially, you find the round trip time. So your round trip type is 4, and then you find uh, extra packets equals to RTT minus patience, I guess. I am not sure if it's already minus patience, if it's already divided by patience. So let's take an example. If the patience was 3, then we would have sent one packet, one extra packet. Okay. Let's take a different example. Let's say the round trip time was um, 20 and patience is 3. Okay, let's take an example. The round trip time is 20, and let's say patience is 3. Then how many extra packets would it have sent? So every 3 seconds it will send the packet till 20th second arrives, right? So means 3 20 divided by 3. So it's coming to around somewhere with the notion of 20 divided by 3, right? And not the other way around. So I'll do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14. So at the beginning of 0 is what it gets, and at the beginning of 20 is when it receives the packet. So now it won't be sending any more, but that does not mean it's won't send any more at 1 second has passed, second has passed, 3 seconds has passed. So it will send one here, and then 1, 2, 3. So 3, it will send one here, it will send one here, it will send one here, it will send one here. Oops, and it will even send one here. And for the cases where it's exactly matching, like 2020, you'll have to sort of say not that it won't send, right? So for example, 20 and let's say 5 instead of, so okay, but first let's do this. So 3 here, so you go 1, 2, 3, 4, 5, 6. So 20 by 3 is 6, so it sends 6 extra seconds, 6 extra packets. But let's say it was 5 now, exactly divisible, right? So if it was 5, then that edge case we need to understand. In that case, well, we are seeing this case of when the packet reaches the 2A packet, when it reaches here, it is not generating another one, right? So that's how you have to sort of rely that it won't generate. So for 2 and 1, how many extra? So it was so for so there is this, and then for 4 and 1, the number of extra packets were. I guess you have to do this minus 1 divided by 1, right? So it's 3 by 1, which is 3. Here you can do 19 by 3, which is 6, and for 20 comma 5, I guess my bet would be 19 by 5, which is 3 and not 4. And we can confirm this here. So it will send one packet at here. 1, 2, 3, 4 seconds have passed. Sorry. So 1, 2, 3, 4. Yeah. So it will send one here, and then 1, 2, 3, 4, 5. It will send one at 10. It will send one at the beginning of 15, and at the beginning of 20 it won't send because yeah, so you got the extra packets, right? So now the math is simple. So you got your RTT is shortest distance times 2, and the other bit is extra packets. So extra packets is RTT minus 1 divided by patience. Now you have to find the idle time. So for this guy, uh, it has to depend upon RTT, right? So there's at least one packet sent. So definitely, does that mean the total packet sent is what? RTT minus number of patients plus 1, and you will calm down only when you get the response of the last guy. I'm getting some simple math here, which is a little bit interesting here. So idle time is when you get the last packet's response, right? So which is your total packets times your patience plus RTT. So everything, the entire math is just coming. It's just math. The only thing that's separating is the total package is also, yeah. I want to see if total package is RTT by patience. Okay, RTT. Is it like twice the RTT? Is that the answer? No, maybe just whatever this is. So it depends on both RTT and patience. So you find the idle time and you find the max idle time, right? Okay, but definitely first you want to find the shortest time and then we just do this math. Okay, so let's first find the shortest time using the Dijkstra's algorithm. So I'm not going to explain Dijkstra's here. I've done it in a previous question. Uh, so how is the representation is like? Representation is like what? Where's example one? Okay, this is how it is. So 0 to 1, 1, and okay, so we have, let's define adjacency list first. So list of edge, right? And okay, this time let's just use pair instead of edge. So list of pair of, all right. So what's the problem here? Everything good? I guess so. So number of edges is what? Edges at length or what? So there were two edges between 0 to 1 and 1 to 2. Hmm. Interesting. So we do not know how many nodes are there then. Yeah. Okay. Let's just get rid of this now. So we can't define a list then. We define a map for each. So you go integer. You have what? You have a list of edges, and we define edge as a pair. So we call this an adjacency, right? Equals to new. Now we'll go through this edges. So for int I equals to 0 is less than. Oh, it's not even a. So you don't need a Dijkstra's algorithm here, right? Because it is the shortest distance. So you just do the regular BFS then. Hmm. Everything because it's all unweighted. So you could just use a BFS, but okay, you still need to define then a graph as an adjacency list still. So you got a map and you got a, instead of a pair, then you just need a list of integer, right? So this is your hash map. Uh, for int I equals to 0, it's less than length. It's not even a weighted graph. It's not even a weighted edge. I mean, sorry. Um, is it a directed edge? No, it's not, right? So it's both. So it's okay. So do u equals to uh, edges of I of 0 and v equals to edges of I of 1. And now what? And now key and value is what? If it's not present, then you wanna just add for both. And okay, so in the adjacency list of U, you are adding V. In the adjacency list of V, you are adding U. Alright, so now we have to do a BFS from what? From 0, right? And find the minimum distance from 0 to all the nodes. And it's given that they are sort of connected and everything. So we define okay, so we need the map.say, right? So yeah, so int array the shortest distance to a node equals to new int of senseless dot size and maybe just initialize to some large values. And now we just do a BFS, and in a BFS we pass adjacency list, we pass this min distance to, well, that's not only two things you need. So you void BFS, you got your adjacency list, you got your distance to, okay. And you know that you want to start with 0. So hopefully there are no cycles as well, huh? So yeah, so visitor equals to new boolean of n and initialize to false, and now we do what? Visited of so you have to call some BFS util with a node, right? And look at all its neighbors. And so should I just start with like do BFS you just yeah BF call BFS 0 and the same things? Should I have done that here there itself? So something like that, and should I have just called it with 0 and maybe define a a visitor array as well, like this, and pass that to like this. And so now you get rid of either both of these, and you here mark. Okay, so you will define another thing which is called level, and you can just call it distance, right? So you do visitor of source equals to true. You go BFS, sorry, not BFS. You go min distance to of source equals to the current distance. And now what? For each node, so for each integer destination you want to call, or what, or neighbor, for each neighbor in the adjacency list of this guy, if the neighbor is not visited, then you call BFS with the source adjacency list, main distance to visited, and distance plus one, right? That's all, I guess. So when you stop when there is no neighbor, right? There's always some neighbor because they're always connected. But at some point you will stop because you won't call this because all your neighbors would have been visited. Makes sense. So you'll stop there, and so you do the BFS with the min distance for each, and now the min distance is set up. Now for each node, I have to find the idle time, right? So you do for -1, and then what? Yeah, you can do 0. And you do keep doing max up, right? So what is the maximum time it will take? So for each guy, you need to check these two things. So first is RTT. So RTT is okay. So you don't look at 0, you look at 1. So RTT is mean distance to I times 2, and then you get your extra packets. So extra packets is what? Extra packets is RTT -1 times patience. Sorry, divided by patience. So you get your extra packets. So you got your total packets equals to, or just called packets, equals to 1 plus, okay, and these are total packets. Idle time equals to total packets times patience plus RTT. Total packets times what? No, this is not right. Uh, Oh, total package times patience is the last. Yeah, so it makes sense. So for example, here in the case of 20 and 3, total packets is what, 4? 4 times patience. Sorry, total packets was 4, right? 1 plus 3, yeah. So 4. You need to know when was the last packet sent, actually. So here the last packet was sent as actually 3. Yeah, so you only consider extra packet, right? Because otherwise it's 0. So it's only the extra packet. So extra packet times that. Interesting. So ignore this. So RTT is definitely what, but idle, so extra packets times uh, patience, supply plus RTT. Okay, and then so you go idle time equals to max of idle times from idle, and then you can return. Now, one more thing to check is there might be some smaller minor things. So, for example, for the 4 and 1 case, extra packets were 3. So you would go 3 times patience, which is what? Patience is 1. So 3 times 1 is 3. 3 plus RTT is 4. So you're getting 7 as the answer, but so you have return plus 1. So you do this. So, or maybe you just do this. So extra packets plus times patience is whatever, plus RTT plus 1, right? So just that, and then yeah. So then you don't. Okay, let's see if this works. All right. So cannot find symbol n. You go here. I just let's say list dot size. All right. Run again. All right. Maybe you're going through some infinity loop. Stack overflow error. Yeah, definitely some infinite loop. So now you have to see why it's going to an infinite loop, especially for the simple case, right? So you're getting 0, 0. Okay, so visited is marked true or not? Visited is getting marked true. There are 3 nodes. Calling BFS, visit is true. Okay, we're calling on the source again, but okay, still visited is true, right? So yeah, but it will keep on running, no? Okay, so you call for each neighbor. That was a mistake. All right, so this works for the first case, and let's go for the second case. No, it does not. So for this basic case, it did not work. It gave an answer as 5. Okay, so let's see this. So maybe you want to print the minimum distance to here, right? Because I'm guessing is your minimum distance also from 0, 1? Yeah, I think it has to be 0 and 1, 1, 1. Okay, so the RTT would be minimum. So the extra package is RTT minus 1, which is 4 divided by 10, 10. So extra package would be 0. So LTM would be 0 plus RTT plus 1, which would be RTT is 2 plus 1, 3. Yeah, so it should have worked. Should have worked. Okay, so the only thing is your maybe your min distance 2 is wrong. So okay, and that's an example test cases. Second last value printed is what we have to check. Yeah, the second last value printed is 2, which is not right. So why is that? Um, Start from 0, all the neighbors. Okay, so this is not BFS, this is DFS. Stupid. You're not even doing VFS properly, man. What? Because you go to one and then you're calling for one, right? You have to do a BFS here. Hmm. So, can I do it recursively then? Okay, let's do what then? Um, let's this and do. So you need a queue. I think it's no. So in Java, do we have a queue now? Okay, forget that. So you add source, and then so adding something to the queue is when you do. Now this is your queue of size. So you pop something out, and at this point you're gonna do distance plus plus, and so you're gonna pop. So you take an item out of the queue, right? And for each integer neighbor in the adjacency list of this node, if they are not visited, then you do what? Two things. One is you mark them visited, and you do min distance to is this guy. Right, so that's all. Right, so this is how you do your BFS instead. Now you run code and see if it still works. Maybe a fucking wrong answer. Okay, so 8333. What happened now? So your answer is 3 and 3. So okay, the first is not working now. Second case is working, the first isn't working. First is 0, 1, and 2. So from 0, distance to 1 is fine. Distance to 2 is not though, because you're not pushing it into the queue. So now you have to see linked list dot add. Does it add to the front or at the beginning? Add to the list, okay. So queue dot add, and you run code. I think now it was going to work fine. Yeah, so an example test cases. Seems like it's working for all. And now I'm gonna remove some printing. And I'm gonna submit. And it works. All right.